Hello everyone. For this tutorial video, I like to explain the final and most complicated stage of using the Blender 3D CAD software, which is rendering your final output. You will notice the first option is the choice between different render engines, and Eevee and Cycles are the ones people use the most. Workbench is used rarely, so I will stick with only Eevee and Cycles. The first option, if you choose Eevee, is the sampling numbers, where render, when you highlight over it, explains it's the number of samples per pixel when you render, and the viewport is the number of samples period. So as a general rule, the greater the samples, the more computationally expensive it is, but also the more smoother, accurate your film will end up as. There is also a simple on-off yes/no checkbox beneath render and viewport called viewport denoising, which simply attempts to remove any noise or similar artifacts from the viewport once it is done rendering. The next option, ambient occlusion, is a little more tricky to understand, but affects the lighting in different ways depending on whether it is on or off. When you highlight over it for the explanation, it says it simulates medium scale and direct shadowing. If you choose to turn it on, you will be prompted for a distance, so the distance of the objects that contribute to the occlusion effect, the factor, or how strong the effect actually is, the trace position, or how precise the search is before it starts the occlusion, bent normals, or compute the normals in a bent manner, and finally bounces approximation, which explains that it's an approximation to simulate the light bounces, giving less occlusion on brighter objects. So essentially, in layman terms, ambient occlusion makes the overall environment brighter using subtle lighting. The next option, bloom, uses a more straightforward approach to make the objects brighter than if you used ambient occlusion alone. In particular, when you highlight over it, it explains that any pixels that have a high brightness value will generate a glowing effect. So instead of calculating the relative distance of the objects from each other the way ambient occlusion does, bloom makes them all light indiscriminately. If you allow bloom, you will be prompted for a threshold, or how sensitive it is before the pixels are considered bright. The knee, or the transition between the under and over threshold. The radius, or how spread out the bloom actually is. The color of the bloom. The intensity of the bloom, or how pronounced the bloom is. And the clamp of the bloom, or the maximum intensity a bloom can have. The next option, depth of field, is non-optional, and you are prompted for the max size of the shape for the depth field. So lower means the depth of field is narrower, i.e. you can only see so much in front of you. The sprite threshold, or the brightness threshold for using sprite-based depth of field. The neighbor rejection, or the maximum brightness to consider when rejecting sprites based on neighborhood. The denoise, or how strongly the flicker is removed. whether you want slight defocus high quality or not, whether you want to jitter the camera or not to create more accurate blurring, and finally an overblur percentage, only if you turn jitter camera on. The next option, subsurface scattering, is not as important as depth of field, but is used for subsurface materials explained in the shading tutorial. So the options are samples, or number of samples you use to compute scattering. More is more computationally expensive, but also gives you a better effect. And the jitter threshold, or how to rotate the samples that are below the particular threshold. The next one is optional and is called screen space reflections, which simply allows reflection on the screen space. You can also turn on refraction if you want. Turn on whether it should ray trace at half the resolution or not, the precision of the ray tracing, the maximum roughness, the thickness of the pixels used to detect intersection, how strongly the edges are faded, and a clamp or limitation of the pixel intensity to prevent excessive noise. The next option is called motion blur and is used to make motion more blurry automatically for you. If you turn it on, you can determine the position of the blur, the shutter of the blur, or the time taken in frames, the background separation, or how strongly you reduce background blending, the maximum blur distance, and the amount of steps or repetitions the algorithm takes. The next effect, volumetrics, I believe does not have any practical use, so I will skip it. The next effect, performance, does not allow you to customize any precise details. It is only a checkbox whether it is high quality or not. The next option, hair, I do not use for video games, as I make the video game characters the old school style, i.e. 90s, early 2000s, when the hair was not realistic. For performance reasons, i.e. realistic hair is very computationally expensive. The next one, shadows, simply controls how the shadows work for all of your solid objects. In particular, you can calculate the size of the shadow, the size of sunlight shadows, whether it uses 32-bit depth or not, soft shadows, and finally the light threshold, or the minimum light intensity for a light to be considered a shadow. The next one, indirect lighting, I do not use for most practical applications, so I will skip it. Next one, film, I do not use either. By similar reasoning, the final options, I believe, are not useful for game design either. And so I choose to overlook / not teach them. The other big option, cycles, has much less options, but the options that it does have work in basically the same exact way as in Eevee. The big difference, however, between the two is the technical way the actual calculations are done. With Eevee, everything is done using approximations or ray tracing. So it uses samples of pixels to render the lighting directly. Whereas Cycles uses the GPU or CPU instead, depending on what you choose on the device option, in order to calculate the lighting in a more realistic manner instead of simulating it using pixels. So although obviously it is more computationally expensive done that way, the trade-off is that you can get much nicer and neater looking effects than with the Eevee engine. Now that I've explained how the rendering engine in Blender works, I can move on to teaching the final part of Blender, which is compositing, which is essentially applying special effects on top of your render. It is not as important as actually making the models and rendering the image. It is simply an extra option / cherry on top. Well, I believe it can still be useful if you want to create neat effects in your project, so I will teach it for that reason.